I've been doing some cleaning up, and I found this at the bottom of a tub. It's from around the year 2000. Active components. I'm not sure if they really exist as they did before. I bought this in Calgary. It's made in Belgium. This is S1803-1. This is version 1. If you go online right now and look, you're probably going to find version 2. Version 2 is much better, and I'll explain the difference later. So, what do you get with one of these kits? And I cleaned this up. It was filthy. You get instructions, and you get a little booklet telling you or showing you what the components look like, where the markings are, and all of that lovely stuff. Then you also, in multiple languages, get the instruction manual. And they even have a schematic. This one is a pretty simple design. It uses LM741. So it's a single op amp. We'll get to the new version in a moment. And essentially you have your audio frequency coming in. Could be a mic. This is your voltage multiplier. And then this was a cheaper version of something much better, where they did the final gain reduction if you wanted to reduce it with variable pot. So, let's see the board. Nice little board, single-sided. Let me bring it up, make sure it's focused. There we go. And the parts. Plus the LM741. So I'm just going to go briefly on before assembling. Here we go. Here's the schematic. So since this is a single supply inverting amplifier, and I'm going to refer to the supply voltage as 12 volts. It can range between, I think it's 10 and 30 volts. So you got AC coming in, but with a single supply, unless you bias it, you're only going to be getting half of your AC out. The positive half. That's not good. So what you do is you bias it. So on the non-inverting pin, if this was 12 volts, pick two resistors, 22 ohm or 22K each. There's the formula, V out equals R4 divided by the sum of these two times the voltage, and so that would equal 6 volts. So you'd have 6 volts here and 6 volts here. Now, for the gain, it's covered by R2 and R1. So R2 is 220K, R1 is 2.2K. The gain would then be negative, meaning inverting. So 220 over 2.2, gain of 100. Then what they do is, not the best way, but they did it on this one. They didn't do it this way on version 2, which I'll cover in a moment. What they then have is you've got a gain of 100, and then it's just a voltage divider through the resistor to get your output. And the other thing is the symbols. I have a tendency of using this symbol here. This is also the symbol for like electrolytic capacitor. And I tend to use this symbol now because it's simpler to draw. And this was the LM741. Now I'm going to pull in and plop right here a screenshot of the version 2, which is much better. In version 2, everything on the left side of the two center capacitors is essentially unity gain. And since they're using an LM358, they've got two op amps in there. So on the first op amp, they're basically just unity gain. On the second op amp, it's set up to do 100 gain. Much nicer way of doing it, and not adding a lot of components. So let's get down to assembling this thing. Before I start assembling, I just wanted to show one thing on these capacitors. The black line is the cathode, and the other end where the crimp is the anode. And I've laid out all the parts so I can just put them in and solder. One thing is that I'm probably going to do stop motion or speed it up. Otherwise all you're going to be doing is looking at the back of my hand. R1. R2. Let's see, where's R3? Yeah, start with the components that lay the flattest. R4. Then flip it over and solder with the good stuff, lead. And if you need to, use flux. Oh, sucks. Better. And a brief inspection. That one's less than ideal if you can see it. Actually, these have a little oxidization on these. Then make sure you have your glasses on when you're clipping. Hold on to the end of it. That way it doesn't go shooting off into space. There. Got the resistors in. Next, capacitors. Okay, C1. Yeah, I should like it a little bit better. C2. Noting the polarity. Oops. There we go. C3. Oops. At the corners. Could have done that better. Could have done a lot better. Okay, now just make sure this fits in there. I don't have anything pushing against it. Okay, and then flip over and solder. Oops, okay, yeah, all good. Guys are in there. Nope, we're going first now. This is bottom. You don't want to spend much time thinking on those lots. Okay, all that's in. Let's check my priorities. And next, the chip. Where's the chip? I'm just going to put that underneath there. Okay, let's try zooming down. Good. Okay, take a quick look. That was a little. I think the lead's oxidized up a tiny bit. Okay, maybe oxidized up quite a bit. There's no big way about using any flux. Other than that, what's in the solder? There we go. Then, insert chip. You'll notice the dot on the chip. Notice this. That's the way it goes in. That's pin 1, 2, 3, 4. Whoops. Pin 1, 2, 3, 4, 5, 6, 7, and 8. So it's now assembled, and now I can test it. Okay, it's not assembled. Okay, just grab a. It's easier. Just need to push them faster a bit. Oh, there you go. Turn the focus. Okay. Oh. Okay. They sent 4 spare pins. They sent 4 spare pins. That's nice one. And just have to flip over and solder them. Yeah, they look good. So next step will be testing it. Okay, it is working. There's output, and if I turn the little knobby, I can change the gain. Both of them are set at 50 millivolts per division. I had a bit of fiddling to get that because my function generator simply won't go that low on output. And the maximum input you can have on this is 40 millivolts on the audio in. So, once I used a bunch of resistors to break it down or lower it, it works fine. If you overload it, you actually start getting flat responses. So that's it. It does work.